Question number 9c is similar to 9b in that we have our cosecant squared theta equals 2, but we have to solve for the ratio first, and we also have to then convert it into sine if we are not as familiar with the cosecant ratio. So our first thing again is we have to solve for the ratio first. So I'm going to square root both sides, and I get cosecant theta is equal to plus minus square root 2. So if you know your cosecant ratios, then we can use that ratio, but most people are more familiar with the sine ratio. So I'm just going to switch that into sine, and we end up with plus minus the reciprocal, which is 1 over root 2. That's a little bit more familiar. 1 over root 2 represents the 45-degree angle, and the sign we're going to have positive 1 over root 2 in this quadrant 1. We're also going to have it in quadrant 2, but because it's also the negative 1, we get in quadrant 3 and also quadrant 4. Now these are different triangles than what we had with other one, because our ratio before was 1/2. This is 1 over root 2, which is a different triangle. But once we've established the solving for the ratio, we can then get our solutions for the angle from the circle here. So we're going to undo that sign. We get an angle of 45 degrees in quadrant 1. We'll call that one theta 1. In quadrant 2, that 45-degree angle is 4 pi over 3. In quadrant 3, that's going to be 5 pi over 5 pi over 4. And quadrant 4 is going to be 7 pi over 4. And that represents 1 period worth of solutions. And since we've only been asked for 0 to 2 pi, we can stop there. Otherwise, we could actually repeat these solutions as we keep going around that circle.